So hello and welcome everyone. I'm Jay Dalsaniya, and in this video we are going to understand how to solve the question palindromic partitioning. So this question is one of the variation of a standard problem of DP, and this question is very interesting to solve. Okay, so we'll be solving this question in a very easy manner. I'll be showing you the most simplest approach to solve this question. So without any delay, let's start. So first of all, what we'll be doing, we'll be understanding how to what the question is trying to say, right? So the name of the question is palindromic partitioning. So given a string str, a partitioning of this string is a palindromic partitioning if every substring of the partition is a palindrome. Okay, so determine the fewest cuts needed for palindromic partitioning of the given string. So what you have to do in the given string, you have to make some partitions at some positions. Okay, so the partitions should be in such a way that the substrings that are present inside each and every partition should be a palindrome. Okay, so now what you have to do, you have to find out that what minimum partitions are required so that each and every partition substring is a palindrome. Okay, I hope you understood how the problem statement means, what the problem statement means. So now let's try to understand with the help of the test case. Okay, so over here, I'll be writing down one of the test case which is given to us in the question. Okay, so the test case is triple A, double B and A. Okay, so this is the string which is given to us. Now what you have to do, you have to find out different partitions possible. Okay, so let's try to find out the output of this question of this test case. So triple A, double B and A. So now let's say if I make a partition over here, let's say if I partition each and every character. So how many substrings which I'll be getting n number of substrings. A, this will be B, this will be B and this will be A. So how many substrings? The length of this string is equivalent to 6. So I got 6 substrings, and what is the number of partitions required? So there are 5 partitions required over here. Right, so this is the worst case for any of the substring, right? So the answer in the worst case for any substring can be n minus 1, just like this one, right? But this is not the minimum number of cuts which are required. Let's say if I partition these strings in this manner, triple A, BB and A. So now over here, if I make a partition over here, let's say this, so my left portion will be double A and my right portion is going to be A, double B and A. So I can see in a single partition, basically I made a single partition and I got 2 substrings and both of them are palindrome, right? So what is the number of partitions in this case? So the number of partition in this case is 1. It is far small compared to 5, right? So this is the minimum number of partitions for this given string, and hence the output comes out to be 1 in this scenario, right? So now let me give you one more example so you can have a clear understanding. So let's say if the string given to you is triple A. Okay, so what will be the minimum number of partitions? So let's try to find out for this triple A. As I mentioned, I can have individual partitions, individual characters, right? So in this manner, and what is the number of partitions in this case? I can see the partition is 2 and the length of the string is equivalent to 3. So this is the worst case scenario, right? But there can be a better number of partitions. So basically, if you observe this string is already a palindrome, right? Already a palindrome. So what is the number of partitions required for this string? I can see the number of partitions required for this string is comes out to be 0. So I don't need to make any partitions on this given input string. Okay, so the worst case answer possible. So basically for any test case, the answer will lie in this range, 0 till length minus 1 of that string. 0 to length minus 1 of that string. So the answer will not go beyond the length of the string and it will not be less than 0. It is not at all possible, right? Negative partitions are not possible. So that is all about what the question is trying to say. I hope you understood the problem statement and I hope you understood each and every example. Okay, so now let's try to brainstorm a little bit and let's try to find out how to solve this question. So in order to explain you the approach, what I'll be doing, I'll be taking the same input number 1 which we were solving over here. Okay, and I'll be working on this input, on this substring. So I'll be having this string triple A, double B and A, right? So this is my substring. So now if I want to make partitions, see, as I mentioned that this quotient is a variation of a different quotient, right? So there is a standard problem available in DP, that is MCM, that stands for matrix chain multiplication. Okay, this is one of the standard and most important problem of dynamic programming. If you have not heard about this problem, I would highly recommend that just have a look at what this question is trying to say, because there are almost, like, let's say 7 to 8 variations of this MCM problem, and this palindromic partitioning is also one of the variation of it. Okay, so that is how this important MCM problem is. So I would suggest after this lecture, after this video, just have a look at this MCM problem. Fine. So yeah. So basically, the MCM problem has introduced a technique called as partitioning, and there are many different variations of this MCM, just like this palindromic partitioning, which will be using this partitioning technique. Okay, and that same technique I'll be using over here. So now let's try to solve this question. Okay, so now according to this MCM, or let's say according to this question, I know that I have to do different partitions, right? So what I will be doing for any given string, let's say for any given string, I will try to find the left portion for that string. I will try to find the left portion. Okay, and I'll try to find the right portion of that string. Basically, I will make a partition on the given string, and I'll get the left string and I'll get the right string. And what I'll make sure is that the left portion is already a palindromic partitioning. That means whichever substring I think that, let's say if I want to keep this part of this string, let's say this is my entire string, and let's say I want to keep this in my left portion, then I'll make sure that this portion is already a palindromic substring. I'm not sure about this right portion. I'll do something about the right portion, but for now, if I make a partition on the given string, I'll make sure that the left portion is the substring which is already the palindromic substring. So for this example, I'll be following the same methodology for partitioning. Okay, so now let's say if I make how many partitions can I make? As I mentioned, there can be n-1 in worst case partition, right? So now what I'll be doing, I'll be trying out partitions at each and every position. Let's say I do partition over here, over here, over here, over here, and over here, right? So I'll make sure that I'll try out each and every combination. So this is going to be our brute force approach. You can imagine this as a brute force approach. Okay, fine. So now over here, let's say if I start the partitioning from this section, I make a partition over here. So what will be my left portion? My left portion will be this, and my right portion will be double A, double B, and A. Okay, so is this a valid partitioning? Yes, because this left portion is already a palindrome. I'm only going to make a partition if my left portion is already a palindrome. Okay, so this is a valid partitioning. So this will be considered as one of the valid partitioning. Now let's say if I make a partition over here. So what will be my left and right portion? So my left portion will be double A and my right portion will be A, double B, and A. Is this a valid partitioning? Have a look at the left part. Have a look at the left portion. This is my left portion. Yes, it is a palindromic substring, right? So this is also one of the valid partitioning. I can make a partition over here. So now let's say to make a partition at some other place. Let's say if I make a partition over here. So what will be my left and right portion? My left portion will be triple A and my right portion will be B, B, and A. So now is this a valid partitioning? Yes, because my left substring is a palindrome. Triple A is a palindrome. So this is one of the partition which is possible. So this partition is also one of the possibility. Now let's say if I try to make a partition over here. So what will be my left and what will be my right section? So my left portion will be triple A, B, and my right portion will be B, A. Is this a valid partitioning? See, focus on the left portion. Is this string a palindrome? No, absolutely not. So this partitioning is not valid according to our ideology, according to our process, right? So I'll not make a partition over here. So this partition will not be considered. So now let's move ahead. On moving ahead, I'll be getting, let's say, this. Okay, so now this is where I'll be making a partition. So what will be my left portion? So left portion will be triple A and BB, and my right portion will contain only a single character A. Now, is this a valid partitioning? No, this is not a palindrome. This left portion is not a palindrome. So I will not consider this as a valid partitioning. So I'll not consider this. And at the end, I can make a partition at the end of the string. So that will be something like this: triple A, the original string, and the right portion will be completely empty, right? So is this a valid partitioning for this scenario? It is not, because my left portion is not a palindromic substring, right? So this is not also not going to be my consideration. So how many valid partitions did I find? I found only 3 valid partitions, right? So now what I will be doing about the right portion? I know that the left portion of this partition over here at each and every position, over here, and over here, they already are substring. They are already palindromic substring. What about the right portion over here? So now for solving the right portion, what I will be doing? I will be making a recursive call, and I'll be doing the same process which I did for this string. I'll be following it for the substrings of the left portion, and I will be doing the same approach over here. Basically, what is our question? So the question is to find out the minimum number of partitions. Minimum number of partitions. Okay, and number, it indicates minimum number. So the output needs to be an integer value. You have to print an integer value in the output, right? So instead of the left portion, I am sure about the left portion. So what I'll be doing, I'll be erasing all the left portion, as I need to find out the number of partitions, no? So I have erased all the left portion. So now, as I know the left portion is already a palindromic substring, instead of including the left portion, I'll do simply +1. I'll explain what is the meaning of +1. Okay, so what does it mean by +1? I am sure that the left portion contained a string A, right? So I made a partition over here, and this is my right portion. So this partition will be considered as one of my partition. So that is the reason I have included one, that I made one partition that is separating the left portion and the right portion, and this right portion will also send me some value. It will also send me some value that for making this substring as palindromic substring, what I'll be doing, I'll be returning how many partitions are required in this right substring. So I'll add 1 plus value, whatever is written by this whatever is written by this right portion. Similarly over here, I hope you understood that left portion is already a palindrome. So I made one partition which separated left and right. So now this right portion is also going to return me some value. So I'll add that value over here, and I'll get how many partitions are required for this one. Similarly over here, this will also return me some value, right portion. I'll add that value to this one, and I'll be getting an idea how many partitions are required. Okay, so there were 3 different valid partitions, this, and this. So all of them will return some value, let's say A1, A2 and A3. And now among all A1, A2 and A3, I need to find the minimum value. So what will be your answer for this question? So the answer for this question is going to be minimum of A1, A2 and A3. Over here you got 3 valid partitions, right? But it is possible that you can get more than 3 valid partitions. Okay, so basically take the minimum of all the valid partitions, and whatever is the number of partitions required for A1, A2 and A3, take the minimum, and that is going to be your answer. Okay, now to elaborate how the recursion will look like, so let me help you. For now, I did not mention that how I will resolve the portion of the right partition, how I will solve the right partition thing. So let me explain you. For solving the right partition, what I will be doing, I will be making a recursive call. I will be applying the same approach for this right portion A, double B and A. I took one of the valid partition, and I am going to show you how the process looks like. Okay, so I have made a partition over here, double A, and this is the right partition, A, double B, A. So now over here, what I will be doing, I will be doing the same process for this right portion, A, double B and A. And I'll try to find out what is the minimum number of partitions, right? So now one by one, let's write. Can I make a partition over here? Left portion will be A and right portion will be B, B and A. Is this a valid partitioning? Yes, obviously. Why? Because this is already a palindrome. Okay, fine. Now let's try to make a partition over here. AB, left portion, and BA is the right portion. Is this valid? No, not valid, because left portion is not a palindromic substring. So I'll not make a partition over here. So moving ahead. So now over here, is this a valid partitioning? Let's see. A double B and A. No, it is not. Left portion is not a palindromic substring. Okay, fine. Now let's see if I make a partition over here. Let's see what will be my left portion. It is A double B and A. And the right portion is empty. Is this a valid partitioning? Yes, Although there is nothing on the right partitioning, but the left portion, left partitioning contains a palindrome. So this is absolutely a valid partitioning. Okay, so what will be the response in this scenario? Left partitioning already contains a palindrome, so 1 plus whatever is the value of this. Fine. And as we know, we are going to use recursion, right? So this empty string, if I try to find out number of partitions on this empty string, what I will get? I will be getting 0. If this string is empty, how many partitionings are required? Basically, you need 0 partitioning, right, in order to make the substrings a palindrome. If the string is already empty, so this will return me 0 over here if I make a recursive call on this empty string. Okay, fine. So now for this partitioning, that was left partitioning contained A double B A and the right partitioning contained an empty string. The minimum number of partitions came out to be 1. Okay, fine. So now we'll think upon this why it came out to be 1. Okay, so now let's try to move ahead. So now let's try to solve this part. Okay, so I know that this is already palindrome, so this will be having 1 plus whatever is the value of this. So let's try to solve this substring BBA. Now over here, left portion is B and BB and the right portion is BA. Fine. Is this a valid partitioning? Yes, it is already palindrome. So let's try to make a partition over here, that is BB and A. Is this valid? Yes, left portion is already a palindrome. Okay, fine. So I got 2 different partitioning. Okay, so let's erase this left portion and let's put 1 over here because I made 1 partition, right? And that separated left and right part. Okay, so now again I'll be doing on this and this. Okay, and now if I make a partitioning over here, so I know that for a single string, what is the number of partitioning required? I know 0 partitioning is required, obviously, because it is going to be already a palindrome, right? So in this manner, each and every step, each and every recursion will be returning some value. Okay, and what you have to do, you have to find out the minimum of all the temporary answer. Let's say you will be getting A12 and you will be getting let's say A11 over here. So you have to find out what is the minimum number of partitioning for this string A double B A, and that will be nothing but minimum of A11 and minimum of basically A12. Okay, and whatever is the answer, that will be, let's say, A1, and that will be the number of partitions required for this over here. If I make a partition over here and this part, this is the answer A1. This many partitions are required. Okay, so to get a clear understanding, I'll be writing down the code. I'll be showing you the recursive approach so you can understand it in a better manner, right? So this is how the entire thing about partitioning will look like in the code. Basically, this is the background process. Okay, so without any delay, let's have a look at the implementation of the recursive approach for this. Okay, over here I have not used any kind of DP for now. I have not used any memoization, but we'll try to memorize this solution and this is going to work perfectly fine. Fine. So this is our method, that is palindromic partitioning. Argument is a string. What I have done, I have just extracted the length of the string. Okay, and now what I will be doing, I will be simply making a function call on this helper function, and the arguments are string, and I have passed one iteration, that is I, and I have passed the length of this string. Okay, so now let's say what is this I and N. Let me explain you with this example. So now over here you might be wondering what is this I pointer, right? So let me explain you what this I pointer is meaning. So this I pointer which I have used over here is helpful to me in order to identify that what is the partitioning length, like basically from where to where did I make a partition. So basically what I did, I had a one variable that is saying I, and I'll be having one more variable that is j. So basically this j will be moving from I till n minus 1, and let's say what I'll be considering in my left portion, the substring, I'll be considering the substring from I to j in my left partition. I'll be considering the substring from I to j in my left partition, and the rest of the substring that will be from j plus 1 to n minus 1 will be considered in my right partition. So that will be from j plus 1 till n minus 1, till the length of the array. This is going to be my right partition. So that is the reason I have used basically to identify if I give the left portion over here. See how this it is, how it will work in the code. So basically I and j currently will be pointing to this. So left portion will be containing A. Now let's say if I move the J pointer forward, so now what will be your left portion? So your left portion will be AA, and what will be your right portion? This much will be your right portion. A, double B, and A. And in this scenario, it will be double A, double B, and A. Now I'll move this J pointer forward. If I move this J pointer forward, so I'll get the left portion as triple A, and this will be B, B, and A. Now let's see if I move this J pointer forward, I'll be getting triple A, B, and I'll be getting B as my right portion. So this is the ith pointer and jth pointer required, right? So whenever, let's say over here from let's say this instance, when I got the left portion and right portion this way, so if I make a recursive function call on this A, B, B, A, again I will be having this I pointer over here and J pointer over here. Again I'll be moving this J pointer forward, and I'll be getting I to J as my left and J plus 1 to N minus 1 as my right portion. Okay, so that is what the I and J means. I hope you understood. So I have passed the value of I, and I have passed the length of this string. Now if the value of I is greater than or equal to N, let's say if I move this right portion greater than the length of the N, or if I value is equivalent to N, at that time it means nothing is present over here. This string is entirely empty. So partitioning answer is going to be 0. So now if I is greater than or equal to N, we completely understood what does it mean, right? So now I have used one variable, that is answer variable, that shows what is the minimum number of partitions required. And I have initialized it to infinite, right? So now I will move the J pointer starting from I till N minus 1. That will indicate my right portion, J till N minus 1, and I to J will be my left portion. So I'll check if my left portion, that is from I to J, is a palindrome or not. So I have created a function that is palindrome. It will check whether the portion I to J of this given string is a palindrome or not. If you don't know how to check a string is a palindrome or not, just get an idea about that algorithm, right? So I have used a variable I and J. I am simply checking the leftmost and the rightmost character. If they are same, then okay. If they are not same, I'll simply return false. This is palindrome will return false in that scenario, right? And if I find that left portion is already a palindrome, then I'll make a function call on the right portion starting from J plus 1 till N. And I have added 1 for this left portion because it is already a palindrome, and one partition separated left and right part, right? So I've added plus 1 over here. Now I'll be getting the answer different temporary variables, right? So I'll take the minimum of all the temporary answers, and I'll be finding out the answer for that particular string, and I'll return it to the parent function. Right, so this is the entire function, and now if I try to compile and run, let's see what we are getting. Okay, so on compilation we got that the answer for this ABC string, basically a very simple string, came out to be 3, but the expected output is 2 actually. So what are we doing? See, over here what I am doing over here, let's say this right portion is running from, basically left portion is starting from I till N minus 1. I have included the left portion from 0 till N minus 1. And it is possible that the right portion will be empty. And in that scenario, I know that if I am including the entire string in my left portion, I don't need to add this plus 1, because I am just simply considering the entire string again, right? So in that scenario, this plus 1 is manipulating our answer. So basically each and every step I am getting one answer plus 1, right? So what I'll be doing, whenever I return this value, whenever I return the answer, I'll simply do minus 1. Okay, so that will be balanced and will be getting the correct answer. And now this is working perfectly fine. Let's try to submit and see. And this is the brute force approach. So obviously this is not going to get accepted. It is showing expected time limit exceeded. Right? So now how to solve this question? Like, let's say what is the optimization thing? If you want to memorize this solution, what do we need? We need a DP array, right? So what I'll be doing, I'll be creating a DP array, and that will be static DP int DP. Okay. And what is the value in this recursive function? Which value is being changing on of calling the functions? I can see this value I is only changing. So what will be the dimension of this DP array? Right, I can see only single value is changing, right? So the DP array dimension is going to be 1D dimension, right? So basically it is 1D DP array. So now what will be the length of this DP array? DP array length is going to be new integer n, and I'll be filling out this entire DP array arrays.fill with minus 1. Fine. And what I'll be doing for safety purpose, I'll just increase the size of this DP array by plus 1. Fine. And now, in order to memorize, before making a function call, what I'll be doing, I'll be checking my dp array. If the value is not -1, if dp of I is not equal to -1, that I can simply return dp of I in that scenario, right? So this is memoization, and I will store the answer over here at this portion. Dp of I is equal to answer. Okay, and this function will be returning the value, and yeah, that's it. And let's try to compile and run, and let's see the output. Okay, so we got an error that says is equal to cannot find the symbol. Okay, so basically let's take this value declaration part over here. Okay, now it will work perfectly fine. Okay, so the our compilation is completed, and now let's try to submit this solution. And we can see that the problem has been successfully submitted, right? So this was the memoization part, and this was the brute force plus dp part for this quotient palindromic substring. Okay, so now let's try to analyze what will be the time and space complexity for this approach. Okay, so over here, what is the space complexity? First of all, let's try to quickly get an idea about the space complexity. One array is required, 1D array. What is the length? It is equivalent to n, right? And a recursive function is required, so auxiliary space will be around, let's say, order of n. So order of n plus n, that is order of 2n, is my space complexity. What will be the time complexity over here? So the time complexity, let's try to understand. So over here, I know that how many times I am doing the partitioning. So this loop is iterating n number of times, and this function is also being called n number of times, right? So as many times I'll be doing the partitioning, this function is palindrome will be called, right? So the overall time complexity of this approach comes out to be order of n into order of n, that comes out to be order of n square, and the space complexity comes out to be order of n. Okay, so that is the time and space complexity of this approach. So that was it for in this video, and I'll be meeting you in the next video. Thank you.